Alright, so in this video I'm going to take a look at the answer key to FRQ number 2 from the 2019 exam, compare it to my answer that I went through in the last video, and then look at some sample student responses and grade their responses. So, if you remember, let's go to number 2. Alright, first question was asking about the bond length in the halogens. And I said, right here, the I2 molecule has the longest bond length since iodine has the largest atomic radius out of the 4 halogens listed in this problem. Iodine has the largest atomic radius because it has the greatest number of energy levels of electrons, as evidenced by it being furthest down on the periodic table. Okay, and the answer key says, okay, so 1 point is earned for circling I2 and providing a valid explanation, and their sample is I2 has the longest bond length because the radius of the iodine atom is greater than the radii of the other halogen atoms. Thus, the distance between the nuclei of atoms in I2 is greater than it is in smaller halogens. Okay, so you didn't even really need to explain why iodine has a greater atomic radius according to the answer key. Now, I did in my answer, and I think it would, probably be good to, and certainly wouldn't hurt to, but apparently it's not required. We just need to mention that. It is iodine, and it is so because it has a larger atomic radius than the others. Alright, so part B was the question about we wanted to produce Br2 using a thermodynamically favorable reaction. So I said, well, that means that we need to flip this half reaction to produce bromine, because right now bromine is written as a reactant. And when you flip the half reaction, you flip the sign of the E0. And so then we need to pick a reduction half reaction, because this one's now an oxidation. So we need to pick a reduction half reaction that, when added to negative 1.07, will make the overall cell potential positive. And so I picked this half reaction, and that gave me this as my overall reaction. Okay, and let's see what the answer key says. So, okay, this is a 2-point calculation, or 2-point question, 1 point for the correct balanced equation, and then 1 point for the correct calculation of the standard cell potential. So this is the correct answer. 2Br minus plus Cl2 gives you Br2 plus 2Cl minus. That's the one that I wrote. And then the cell potential is positive 0.29 volts. They're showing another way to calculate it. To calculate cell potential is you can, rather than technically, it really ends up being the same way, and I prefer calculating cell potential this way, where you flip the 1/2 reaction. But there's another equivalent way of doing it, which is what they're showing here, which is where you don't really flip it. So you leave the Br2 as 1.07, but you just subtract the half cell potential of the oxidation half reaction. So since the bromine, since it's the reverse reaction of this that is occurring, it's an oxidation half reaction, and so you just subtract that value. I prefer doing it this way, where I just actually flip the sign of the cell potential and then add them together, whereas they're not changing the sign, but they're subtracting it. So if you do it this way, it's fine, but that's another way of doing it. Obviously, we got the same answer. And then they wrote a sentence similar to what I did, saying that because E0 is positive, the reaction is thermodynamically favorable. Again, I don't think that sentence is strictly required based on their scoring guidelines, but it certainly wouldn't hurt to write. Okay. Part C was about explain why Br2 has a higher boiling point than BrCl in terms of intermolecular forces. And remember, we said that Br2 is nonpolar, whereas BrCl is polar. So based on that, you would actually expect BrCl to have a higher boiling point. But since Br2 is a larger molecule with more electrons, it is more polarizable, and that can allow it to actually have a higher boiling point despite being nonpolar. And they say, okay, so take note that they started their explanation similar to how I did. Remember I said, so let's see what the question is specifically asking. It says, explain this difference in boiling point in terms of the intermolecular forces. And I said, you don't have to immediately answer the question. You don't have to write it in TQAA form. You can just start by listing background information and work your way up, build the background, the context, before you're actually ready to answer the question, which is what I did. I just started by describing Br2 and BrCl and their intermolecular forces before I really answered the question they're asking. And while it's not strictly necessary to do that, I do think it's a little bit better, and that's how they're doing it too. They're just starting by saying the only intermolecular attractions in Br2 are London forces or London dispersion forces, while those in BrCl include both London forces and dipole-dipole forces. However, due to the greater polarizability of the electron cloud of Br2, and again notice they're using the word polarizability, so I would use that word anytime we have this phenomenon occurring where you have a larger molecule that has a higher boiling point because it's larger and it has more electrons. I think it's good to use this word. It's more polarizable or has a greater polarizability. So it has a greater polarizability of the electron cloud of Br2 compared to that of BrCl. So the London forces in Br2 are stronger than the combined intermolecular forces, London dispersion plus dipole-dipole, in BrCl. Thus the boiling point of Br2 is greater than that of BrCl. And so this is one point for identifying the intermolecular forces in each substance, and then another point for explaining how that contributes to Br2 having a higher boiling point. Now remember I mentioned this in the other video, because this one's a little bit complicated. I don't think they would expect you to predict that Br2 has a higher boiling point than BrCl, because we have kind of competing factors here. BrCl is polar, whereas so that would suggest BrCl has a higher boiling point, but Br2 is larger, which would suggest Br2 has a higher boiling point. So I don't think they would ask you to predict which one has a higher boiling point, but you should be able to, if you're given what their boiling points are, explain why that can be true, why Br2 can have a higher boiling point than BrCl, given that it does. Okay. Alright, so then D was calculating the pressure in the container before equilibrium was established. So this was just using the ideal gas law because all we had was the BrCl gas, 0.1 moles of that. And so that's what I did here. Or where did I do it? I don't know why it says F here. Yeah, I did it right here. Sorry, it's kind of messy. Got a lot going on. So right here, we just took the 0.1 moles of BrCl gas, and then they gave us the temperature, the volume, R is a constant, and then we calculated the pressure using the ideal gas law. So pretty straightforward. That's just a one-pointer. Okay, then it said write the expression for the equilibrium constant. Now I said you can do either Kc or Kp. You should only do one. And I said I think it would be better to do Kc. And actually I used Kc for the subsequent problem. But I think you can do it with either one here, because everything is a gas. Yeah, and it doesn't specify which one to use. So, yeah, and the answer key even mentions you can do either one. You can do concentrations or you can do pressures, but it should be, BR2 times CL2 on top and then over BRCL squared on the bottom, since BRCL has a coefficient of 2 in the equation. Okay, it's just a one pointer. And then after the system has reached equilibrium, 42% of the original BRCL sample has decomposed. Determine the value of K for the decomposition reaction. So I said if 42% of the original BRCL sample has decomposed, that 58% remains. And so I set up an ICE table. Okay, so this was our initial, and I'm doing molarity because I'm using my Kc, so that's in terms of concentrations. And remember, I got this molarity because I did 0.1 moles over 2.0 liters. So moles over liters is molarity. So I have none of the other ones. This is minus 2x, this is plus x, this is plus x. And then if 58% of it remains, then that means that I have 0.029 molar of BRCL at equilibrium. And then I use that to solve for x, plug that in to find my equilibrium concentrations of BR2 and CL2, and then plugged in all my equilibrium concentrations into my K expression to calculate K, and I got 0.13. And okay, that is correct. So now they did it in terms of atmospheres here, as you can see, which is perfectly fine. So that's why our numbers are, that's why the numbers they have in the ICE table are different than mine. But note that they did obtain the same value for K as I did, which won't actually always be true. Kc is not always equal to Kp, but it is in this reaction because we have equal number of moles of gas on both sides. And that's actually not something that you need to know, but just pointing that out. In this case, Kp and Kc are the same because I have 2 moles of gas on each side. But if I had different numbers of moles of gas, then they would differ. So in this case, they're the same, and so it didn't matter which one we used. They're doing it here in terms of pressure. Oh yeah, see, it makes this note here. The solution is in terms of pressures. Solutions in terms of molar concentrations also earn full credit. Okay, so we just have to correctly calculate the equilibrium concentrations of everything. So basically set up an ICE table and then calculate the correct value of K to get full credit for that. Okay, and then lastly, using this table, we had to calculate the bond energy of the BRCL bond, and I said for that, we're going to use this equation here. Delta H of the reaction is the sum of the bond energies of the reactants minus the sum of the bond energies of the products, because reactant bonds are broken, which is a positive delta H. Endothermic product bonds are formed, which is exothermic, and that's a negative delta H. So that's why we do reactants minus products for the bond energies. And so we just plug everything in. We have to multiply the BRCL by 2 because we have 2 BRCL molecules, so two BRCL bonds. And I got 219 kilojoules per mole. And yeah, they basically set it up the same way. Delta H equals the sum of the bond energies broken, or in other words, the reactants, as the reactants are broken, minus the sum of the bond energies formed, which are the products. And then they just set it up like this and got 219. Okay, so that is the answer key and a review of my answers. And now I'm going to look at some sample student responses. So just again, just to remind you, if you're on this page where the old FRQs are located, this is the answer key, the scoring guidelines. And then I'm going to go to sample responses for question 2. And they actually also have the answer key at the beginning of this document, or the answer key for this question. So you can find it there if you want. I'm going to scroll down to the sample student responses, which start here. And actually, I've copied this into my Word document because it won't let me write directly on here. So what I'm going to first do is I'm just going to grade these responses myself using the official answer key. And then I'm going to see how they were actually scored and compare them. And yeah, this can just give you better insight into how the FRQs are scored, and then what is required for each specific question to receive full credit. So this student for number 1 said I2 has the longest bond length because each bonded atom of I has a large atomic radius due to its greater number of electron orbits. Okay. Okay, I like this, but again, remember, it's not actually required in the answer key. They just wanted us to mention that it has a larger atomic radius, but we didn't need to necessarily explain why. But they did mention a large atomic radius. I would prefer them to say a larger atomic radius because we're comparing, but still. This increases the distance between the bonded I atoms and makes the bond longer. Yes, again, really it's the distance between their nuclei. But yes, this is going to receive a point. Again, like there's little things I can nitpick with the answer, but when it's just 0 or 1 point, it doesn't have to be completely perfect. As long as you pick the correct one and then you give an explanation that's on the right track, even if some of the wording is not perfect, I'm going to give you full credit. And that's kind of how most of these go, especially if they're just 1-pointers. So B, again, they have 2 Br minus plus Cl2 going to 2 Cl minus plus Br2. So that is the correct reaction. And then this is the correct cell potential, positive 0.29 volts. And again, as you see here, they set it up like I did. They actually wrote this kind of wrong because this is for this half reaction, and this is for this one. But they set it up like I did, where they flipped the half reaction and then wrote the cell potential as being negative. They just wrote it kind of in the wrong place. And I guess we'll see. I'm, they did write this out of order, but I don't think that will dock them, because again, they did write the correct equation, and then they got the correct cell potential, and then they also wrote this sentence after it saying E0 is positive, so delta G is negative, which that is true, and the reaction is thermodynamically favorable. Now, you don't have to mention delta G is negative. You don't even necessarily have to write the sentence at all, but even if you do, you don't have to mention delta G is negative, because E being positive is just enough to prove that the reaction is thermodynamically favorable, but they are right. When E is positive, delta G is going to be negative according to this equation. Delta G equals negative NF E0. So basically, delta G and E0 always have opposite signs due to this negative sign in the equation. So that is true, but yeah, you don't necessarily have to write it. Just E0 being positive is enough to prove that the reaction is thermodynamically favorable. But I'm going to give them 2 points for this one. Okay, and then C, Br2 has London dispersion forces only, good, while BrCl has London dispersion forces and some dipole-dipole forces due to the electronegativity difference between Br and Cl. Good. However, the greater London dispersion forces between larger Br2 molecules are stronger than the combined London dispersion and dipole-dipole forces between BrCl molecules, so the boiling point of Br2 is higher. Okay, good. So they mentioned the intermolecular forces present in both substances, and then they mentioned that Br2 is larger, okay, which causes its London dispersion forces to be stronger than the combined London dispersion and dipole-dipole forces between BrCl molecules. Good. So they did not use the word polarizable, which I said would be a good word to use, but again, don't have to have a perfect explanation. I think it's still a very good explanation. That main thing is it touches on these two criteria. Okay, D was calculating the pressure using the ideal gas law. Okay, they did that, 1.22 atmospheres. That's the correct answer. E was writing the K expression. They did that using concentrations, which is fine. And that's correct. And then F, calculating the value of K. All right. So they set up the ice table. All right, so right here, they're showing that. Now, they did it a little bit differently. So remember, I did the thing where I said if 42% decomposed, then 58% remains. And that told me that, the amount there at the end is, this. Well, they just used the 42% and basically said 42% of my original concentration is 0.021 molar. So that's the amount that decomposed. So that's the change is here. Okay, and then, yeah, I mean, I guess I would prefer them to write minus 2x plus x plus x, because then that helps me see where they're getting this number. But that's basically where they're getting this number, because remember, this would be minus 2x, so 0.021 is equal to 2x, so x is equal to 0.0105. So that's where that number is coming from. So again, I'd prefer them to write it like I did with minus 2x and plus x, just to be a little bit more clear, but I think it's fine, because again, this is only really asking that we get the correct values at equilibrium and the correct value of K. And you do have to show your work, but there's different ways to show your work. So it's fine. They got the same values that I did, 0.105 times 0.0105 times 0.0105 over 0.029 squared. And they got 0.131. Yeah, I think technically we would do 2 sig figs also instead of 3. But they don't have sig figs listed on here. So again, as far as their criteria, I'm going to give them 2 points. But we'll see. And then G was calculating the bond energy. So they set it up, delta H is equal to the sum of bonds broken minus sum of bonds formed. And yeah, they're just calling the BrCl bond energy X, which I wouldn't do. I would write it as BrCl like this, but again, it's not that big of a deal. If you call it X, yeah, they got the right answer. So that's a point. So yeah, I think I gave them full credit. Again, only some minor squibbles that I can have with some of their answers, but generally that, again, when these are only worth 1 or 2 points, a minor squibble is generally not going to be enough to cause you to lose points. So yes, this student scored a 10 out of 10. And I don't think there's really too much to see here. I think it was pretty clear that everything would receive full credit. I'm just scanning to see if there's anything specifically that they noted here. Yeah, I mean, if you want to read through that, you can, but I don't really think there's anything really to note. I think it was pretty clear that they deserve full credit for each of their answers. Again, doesn't mean that all of their answers were perfect, but they addressed what the answer key required them to, I think, pretty clearly. So I don't think there's really too much to add there. Again, while it's good to see what's required for full credit, I think often it's more instructive to see responses that don't receive full credit and why. Okay. So the next student, for part A, says I2 has the longest bond length since it has the largest atomic radius, since it has the most shells, as in energy levels. Good. I think that's pretty clearly deserving of a point. They picked the correct element, and they mentioned that it's because it has the largest atomic radius, and then, again, according to the answer key, that's really all you need, but they do go one step further and briefly explain why it has the largest atomic radius. Alright, so the next part, okay, so this is the equation they're writing. Which differs slightly from this equation, but if you look closely, the only really place it differs is the inclusion of these Na ions. If we wrote the net ionic equation, which would cause the Na plus ions to be as spectator ions, we would still produce this equation. And it does tell us that the teacher has access to NaBr, Cl2, and I2. So really, the source of the Br minus ions would be NaBr. And so even though they write it slightly different than this, I think it is perfectly fine to write it like this. I'm just keeping in mind that this is not the net ionic equation. This would be the net ionic equation. But it doesn't ask for the net ionic equation. It just asks for, write the balanced equation for the thermodynamically favorable reaction that will produce Br2 when the teacher combines two of the reagents. So yeah, I didn't even think about that, to be honest with you, that we would actually be using NaBr, but we would be. So I think this is perfectly fine to write it like this. And then they calculate the cell potential correctly. They get a positive cell potential. And then again, they use this equation that I mentioned with the last student to show that if E0 is positive, delta G is negative. And so the reaction will be spontaneous. Which again, you don't have to do that. So you don't have to say, it's spontaneous because delta G is negative. You can just say it's spontaneous because E0 is positive. But it works. So that was a 2-point problem. Good. And I actually like that the student was thinking about this, kind of reading the whole question and keeping in mind that the source of the Br minus ions would be the NaBr. Certainly you don't have to do that, but certainly I think it's fine too. And yeah, even kind of shows me that they're kind of thinking maybe even a little bit more deeply about it. Okay. So C, they say that between molecules of Br2, there are London dispersion forces present, and there are also London dispersion forces present between molecules of BrCl. Br2 has a higher boiling point than BrCl because the intermolecular forces between Br2 molecules are stronger since Br2 has more electrons than BrCl. Okay, so I think this part of the answer is good. And nothing that they said in the first sentence was wrong either, but they did not mention that BrCl also has dipole-dipole forces. And even though that's not the most significant thing in this question, the more significant thing is that Br2 is larger. That's what's causing it to have a higher boiling point. The answer key does specifically say 1 point is earned for identifying the intermolecular forces in each substance. And they did mention there are London dispersion forces present in or between molecules of BrCl, but they didn't mention the dipole-dipole forces. So I'm only going to give the student 1 out of 2 points for this. That's the only thing they were missing, but I think it's a big enough thing to cause them to lose a point. Okay. So the next question was the pressure initially, which, just used the ideal gas law, 1.22 atmospheres, so that's a point. E was the K expression. Okay, so the student wrote that correctly, so that's a point. Okay, F, they did the ice table. And again, again, this is kind of what I was mentioning previously. I prefer the way this student showed this. Again, as we saw, the other students still got full credit, and so it's not that big of a deal, but I prefer when it's shown like this, as with specifically the minus 2x, the plus x, the plus x, because that way they're showing where this number is. It's a little bit more clear to see where this number comes from. And again, they're showing this to illustrate where the 0.021 is coming from. It's 42% of the initial concentration, because the question mentioned that 42% of the original sample has decomposed. Okay, so I slightly prefer the way that they are showing that. And then they get 0.0105 as the equilibrium concentrations for these, 0.029 here, and then the equilibrium constant being 0.13. Rounded to 2 sig figs, which is correct, but as we saw, the previous student did not lose points for rounding it to 3 sig figs. Okay, and then lastly, this question about the bond energy of BrCl. Okay, so they're writing it a little differently, but remember, it's just the bond energy is broken minus the bond energy is formed. And in this reaction of 2BrCl going to Br2 plus Cl2, this and this are being formed. So the student is subtracting each of them, which is correct. I would just typically write it as 2BrCl minus kind of the BrBr plus the ClCl like this. But if you distribute this negative sign, it's the same thing as this. So it works. And I get 219 kilojoules per mole, which is the correct answer. Okay, so I think I just docked the student 1 point for their explanation in part C. So I gave them a 9 out of 10 is what I scored it as. So let's see what they actually received. They did. They received a 9 out of 10. And let's see, I'm pretty sure that they'll lose the point for what I said, but let's see. Student received 1 point in Part A. Part B earned 2 points for a correct balanced equation, cell potential, and stating the reaction is thermodynamically favorable because E0 is positive. Okay, so remember I noted that in B, they wrote it a little bit differently. They wrote it like this with the Na involved in the equation. And I was pretty sure that that would not cause them to lose points, but it is good to see that that actually is the case, since it did look a little bit different than how they had it in the answer key. And then, yeah, they only received 1 out of 2 points for Part C. The first point was not earned. Remember, the first point for that was identifying the intermolecular forces in each substance. And that was not earned because the student incorrectly identifies only London dispersion forces in BRCL and not the dipole-dipole forces. But they do correctly state that the intermolecular forces are stronger in BR2 than they are in BRCL, and that's, so they do receive the other point. And then, yeah, they received full credit for all the other parts, which I think was pretty clear. Okay, so overall, I actually thought the student did a really good job with their response. They just missed that that thing about the dipole forces for BRCL in Part C. Okay, and then lastly, the third student here. Okay, so it looks like they originally wrote I2, but then they crossed it out, which also, they have another thing here. I didn't copy it in, but they did kind of the same thing on here. They circled I2 and then crossed it out and then circled F2. So unfortunately, that I don't think that that's going to work. If you do something like that, they're going to go with your answer that's not crossed out, even if your original answer was correct. So the answer they eventually went with was F2, which we know is not correct because it is the smallest atom, and F is the most electronegative of all the other atoms. Therefore, it can push away from the other F atom the most, making the longest bond length. Okay, so yeah, it turns out that's not how it works. We're just looking for the largest atoms, because the larger their radii are, the farther apart their nuclei will be, and that will make a longer bond length. Okay, Part B looks good. Check, or not here. If we check the answer key, Br2Br minus plus Cl2 going to Br2 plus 2Cl minus. That's what they have, and the cell potential is 0.29 volts. Now, they did not write an additional sentence after the way that the answer key has, and I do, and the other students did, but if we look at this part of the answer key, the scoring breakdown, it doesn't say we need to write the sentence. It just says we need the correct balanced equation and then the correct calculation for the cell potential. And so I think this should receive 2 points. All right. So C, they say Br2 has London dispersion forces. BRCL also has London dispersion forces. Br2 has a greater LDF because of its high polarizability than BRCL. Okay, so a pretty similar response to the previous student. They mentioned that both have London dispersion forces, and Br2 has greater London dispersion forces because I think the previous student mentioned there's more electrons. This student mentioned it has a higher polarizability. But they both forgot to mention that BRCL also has dipole-dipole forces, and seeing that the previous student lost a point for that, I'm very confident this student would also lose a point for that. I was pretty confident before I saw that anyways, but definitely after seeing that even more so. Okay, D was the pressure, and okay, so they did use the ideal gas law. They did set it up correctly, but they multiplied by 2. I'm not really sure why. Maybe just because of this coefficient of 2, they thought they had to multiply it by 2. But no, that's not how it works. And unfortunately, with this only being a 1-point question, they're going to receive no points, even though that's the only thing wrong with their answer. So if it's a multi-point question, you can get partial points, but they don't give out like half points. If it's only a 1-point question, they don't give out like half points on these. So if it's a 1-pointer, it's either 0 or 1. So that is going to be a 0, unfortunately. And then E, okay, their equilibrium expression looks good. That's 1. F. So they set up the ice table. Mostly correctly. There is an issue here, which is that the 0.1 is in moles, though, which you don't want to be in moles for an equilibrium ice table. You actually can be in moles, but then when you plug it into the K expression, it needs to be in molarity if you're using concentrations, or atmospheres if you're using pressure. So we can do our ice table in moles, but then we would have to divide everything by liters at the end before we plug it in the K expression. So generally, if you're going to do in terms of concentrations, it's better to just put them in molarity in the ice table. But otherwise, their ice table is set up correctly, and then they take their equilibrium values, plug it into the K expression correctly, but obviously they don't finish the problem from there. So this definitely is not going to receive 2 points, because this was a 2-point question. I'm debating whether to give them 1 out of 2. Yeah, it's either 0 or 1. I think I'm going to score it as a 0, just because if I look here at the answer key, so obviously they did not calculate the value of K. And they also did not really calculate the stoichiometric values at equilibrium, even though they set up the ice table. And then you throw in the fact that they're using moles in this ice table, which is not quite correct. And it leads me towards a 0, even though they did parts of the question correctly. Maybe it's a 1. I'll be interested to see, but if I had to go 0, 1, I'm closer to a 0. Okay, but yeah, they still did parts of it correctly. For the most part, the ice table is correct, just if it would be in molarity instead of moles. And then the student didn't, I don't think, realize how to go further from there. Which, remember, to go further, once we get to that point, we need to use the fact that 42% of the original BRCL sample has decomposed to determine, as I did, that. So this is how I set up the ice table, which looks very similar to the student, other than mine's 0.05 because I did molarity instead of moles. But then once we get here, we realize that our equilibrium concentration of BRCL is 0.029 molar due to the fact that 58% is remaining. And then we can solve for X, get our equilibrium values, and calculate for K. All right, and then lastly, part G from the student. Delta H. So they did products or the bonds that are being formed minus the reactants, or the bonds that are being broken. And so that is not the correct setup. Remember, it's bonds broken minus bonds formed, because breaking bonds is endothermic, which is a positive delta H, and forming bonds is exothermic, which is a negative delta H. So that's why we subtract the product bonds that are being formed, because those release energy. And so again, even though a lot of what they did is good here, this is only a 1-point question, and that initial setup is not correct, and they don't get the correct answer as a result. So this is going to receive 0 points, even though they did some stuff correctly. So yeah, on some questions, again, if it's a multi-point question, you can get 1 out of 2. But a lot of these questions are only 1-pointers, and so it's basically all or nothing. So just, I don't know. I guess keep that in mind. I don't know if that would affect how you approach a problem, but just, I guess, if that helps you in any way, or is interesting to you in any way, I guess keep that in mind for how the free response is going to be scored. But anyways, I gave this student 1, 2, 3, 4. 4, is that right? 1, 2, 3, 4. 4 out of 10. So let's check that with what they actually received. They did receive a 4. So let's see if their scoring aligns with mine. So in part A, no point was earned for stating that F2 has the largest bond length. Right. That one's pretty clearly not the correct answer. The response earned 2 points in part B, 1 for the correct balanced equation, and 1 point for the correct value of E0. Okay, that's what I scored it. Remember, you didn't need to put this sentence, even though I think it would be good to include, and a lot of the other responses did. If you check the answer key, it does not require it. Even though they write it here, they don't write it over here where they're saying what's required for credit. And then one out of 2 points was earned for part C. Similar to the previous student, the student incorrectly states that BRCL has only London dispersion forces, so they don't mention the dipole-dipole forces in BRCL, but they do correctly state that the LDFs in BR2 are stronger than they are in BRCL due to its higher polarizability. So they get 1 out of 2 for that. Part D earned no points because, again, the student set up the calculation perfectly except for multiplying by 2. So the student incorrectly multiplies the number of moles by 2 when calculating the pressure of BRCL. And like I said, it's all or nothing. It's only a 1-point question. So they get 0. E, they did correctly, so they received a point for that. F, yeah, they earned 0 points for F. So this was the one I had the biggest question about. I said, obviously it's not 2 points because they didn't, even end up calculating a value in the end. But I was wondering if it was enough to get 1 point since they did set up the ICE table mostly correctly. But no, I said ultimately I would lean towards a 0, and that is what they received. Because the student does not determine the equilibrium values or calculate for KEQ. So you see they're really following this answer key, or the scoring guidelines, which says you get 1 point for calculating the equilibrium concentrations correctly, and 1 point for calculating the equilibrium constant correctly. And even though the student did some of the setups to the problem, they didn't do either of those things. And so they're really just following this and saying they didn't do either of those things, so it's 0 points. And then part G earned no points because the student reverses the terms in the relationship between the enthalpy change for the reaction and the bond energies of the reactants and products. So yeah, they did products minus reactants instead of the other way around, and they got the wrong answer as a result. So that is all for this question. So hopefully the question makes sense, and looking at some of those student responses was instructive for you to see, how that question would be scored and what you need to do to receive full credit. All right, guys, have a good day.